at question 26b from the 2013 revised higher paper. This question relates to a cyclotron. Let's have another look at it. And it says, inside the Ds, a uniform magnetic field acts on the protons, determine the direction of the magnetic field. Now this is one of those questions where I would pretty much guarantee that 50% of the pupils in Scotland probably get this one wrong. And you have a 50% chance. So the magnetic field acts on the protons to change the direction of the field. And if we look at it carefully, what's happening is that whenever the proton enters the field in this side, it moves in that direction. So therefore it experiences a force upward here, and it continues to experience a force roundward. Let's just draw some of those on it. So at this point it's experiencing a force upward. Whenever it's here, it's experiencing a force in that direction. Whenever it's here, it's experiencing a force downward. So that's the size of the force, or at least the direction of the force. And whenever it enters this section, it also experiences a force inward. So essentially inward toward the center of the circle all the time. And so the key thing there to realize is that this force is perpendicular to the direction of motion, but it also must be perpendicular to the direction of the magnetic field, which means since the motion here is in that direction and the force is downward, then perpendicular to both of those motions has to be either into the page or out of the page. And so whenever you do the guess of which one it is and you write your answer, it's either going to be determine the direction of this field into the page or out of the page. Definitely not down the page, definitely not up the page, definitely not left or right. So then we need to determine which way to do this. So I'm going to put on the little webcam here and talk through. This is one of these rare occasions where I actually get on camera and use my hands. So the way I teach this and the way I do it is I use my left hand. So I'm going to hold up my left hand, and this might be a bit confusing on the video, because on the video this is looking like it's my right hand. But the idea is that I've got 3 fingers, and the first finger I called my field. And so that's the direction of the magnetic field. The second finger is the direction of the current, or in this case the proton beam, and the thumb is the direction of the force. So I'm going to take one position on the diagram, which is this one right here, and I'm going to think about what's happening to the proton. So the first finger field, well, at the moment I don't know what direction that's going in, but I do know that the thumb, which is my force, is upward. So I'm going to point my thumb upward. I also know that my middle finger is in the direction of current, so I'm going to point that in the direction of the current, which is in that direction. And so therefore, my first finger, which is the field, at this point is pointing into the page, and as you can see, it's pointing into the camera. So I can determine then that because I'm using my left hand, and that stands for conventional current or protons, then it's going to be meaning that the magnetic field is traveling into the page. And so that's essentially it. It's quite difficult to remember that left hand stands for conventional current or protons, and right hand you would use for electrons. And so in this case, you just have to remember left hand protons, and then you remember what the fingers mean. So hopefully that's helpful. It's one of these things that you kind of either know it or you don't. So best of luck whenever it happens to you.